three looms we've got here. The loom on the end with the orange cloth, that's a Lancashire loom. That could only weave plain cloth, and that loom was second hand in 1867. So that would have been one of the first power looms. These two looms here, these are both Yorkshire looms. These can weave denim, deck chair material and tea toweling, and these looms were built in 1894. Now the threads which go from the back of the loom to the front, that's the warp, and the thread in the shuttle which goes from right to left, that's the weft. The warp's brought into the mill on a roll like the one on the floor just here. That gets attached to the back of the loom. Then each one of these threads, there's 1,200 of them. Each individual thread has to go through these two heels, goes through the mesh in there, and that opens the warp up like that. Then the eels, they go up and down like that. That opens and closes the warp as the shuttle goes through, and that's what knits the material together. Now, it can take up to 2 days, depending on your skill, it can take up to 2 days to set one of these looms up from scratch. But once it's set up, you'll get about 800 yards of cloth from it. Now, as just before the old warp runs out, what we'd have done, we'd have tied the new warp to the old warp, and we'd have just pulled it through. And that might only take a couple of hours. So we didn't want the machines shut down for too long. Now, this is called a flying shuttle, and this travels at 60 miles per hour. Now, it is well named because on one occasion it actually flew out of the Lancashire loom all the way over here, and that's what caused a little dint in the door just there. So if I'd have been stood here, I'd have had a nasty headache. But thankfully that's rare, but that's one of the dangers. Well, there's many dangers, but that's one of them. One of these, we've got a metal bump on each end, and they're quite sharp, and they're just there to give the wood a bit of protection. And one of these would last about 9 months before it needs to be replaced. Now, this is a pern, and this is fully wound with thread. The machine just there, that's called a pern winder, and that's what puts the thread onto the perns. So when we've got a fully wound pern like this, that slides onto the shuttle, and that gets closed into position. Now, with these old shuttles, the tricky part was getting the thread through that little hole there. Now, what they used to do about 70, 80 years ago, they used to put the mouth over the hole and suck the thread through, like that. Now, this was then nicknamed the kissing shuttle, but this got banned in the 1950s for health reasons. What had happened is they sucked the thread through, fibres from the cotton would have gone down the throat and got on the lungs, and that was known as weaver's lung. Also, you'd have hundreds of workers all kissing the same shuttle, and that would have passed colds and all sorts of diseases around. And so that was eventually banned. After that, each loom was fitted with one of these. It's basically a bent bit of wire with a handle, and they'd use that just to get the thread through the hole. Now, they did moan about it, it took them 2 or 3 times as long, but it did actually save lives. On the shuttles we use at the moment, they've just got a little slit down the top, and that just guides the thread into the slit and straight into the hole. It's a lot easier, it's much quicker, less messing around. Now, if I take this middle loom as an example, the fully wound pern, that will keep the loom running for about 15 minutes and produce about a yard of cloth. Now, when the pern runs out, the loom will automatically stop. Now, it is important that it does stop, because if it doesn't, the warp will keep coming forwards, but because there's no thread in the shuttle, there's nothing to knit it together. And that's when we end up with imperfections in the cloth. Like that. Now, any imperfections would have been deducted from your wages. Now, you didn't earn a lot to start off with, so the last thing you wanted was any deductions. So it was important that the looms were in good working order. Now, I can show you how the loom stops. It's quite a clever little invention. Now, that there is called a weft board. So when the beam comes forward, the weft touches that, and that sends it up in the air. You might have noticed when the machines were running. But when the weft snaps, or if it runs out, that will stay down, that gets caught behind that little lid, and that will trigger the mechanism, and that will turn the machine off to release it. So that's how that works. Now, one person would have had 8 looms to look after. They'd have 4 in front of them and 4 behind, and they'll be constantly going around, changing the perns, making sure the material's knitting together properly. Should anything go wrong with the looms mechanically, the man stood in the middle of them, just over there, he was called a tackler. It was his job to maintain the machines, and if any should break down, he'd be there to fix them. Young children were also employed to work on these machines. See all the fluff underneath the Lancashire loom there, and that would have had to be kept spotless, so the children would have had to keep going under there and brushing all the fluff out. Start off with, it would have been why the looms were working, but then a law was passed in 1906, which meant the machines had to be turned off by people cleaning them. But yeah, before then, they'd just been expected to go under all the machinery like it was running. Right, so that's these three looms. I'd like to have a look down here. I can tell you a bit about the jacquard loom. Just at this one here. Right, now this is a jacquard loom. This one was built around 1920, and the punch card system used by these machines was the first computer system. This is how computers started out. Now the punch card goes round. When it gets to the top, the mechanism closes and a set of pins will penetrate the holes, and that causes a number of the strands of the warp to be pulled out of line. Now the ones which get pulled out of line, they don't get woven in, and that's how the pattern's created. This is a paisley design, and this gives you some idea of the good quality material this machine could produce. Yeah. Now, on the looms we've just seen, which only use one shuttle, a jacquard loom would use up to 6 shuttles, and that's how they got the different colours into the pattern. Now, there was a downside to this machine, and that was the threading up of it. There was 4,400 ends to thread up, and it would take 2 men 2 weeks to set this machine up correctly. That made the material very expensive. Only the rich could afford it. Nowadays, it's all done by computer, so it's a lot easier and it's much more affordable. Now, I can show you a single thread, just to show you the difficulty. Bear in mind this would have been done under candlelight as well, but that's a single thread. I'll just put it down now a bit so you can see it a bit better. It's just like a strand of hair, very, very, very fine. And that would have to be threaded through that little eyelet there where my finger is. So that would have actually been done 4,400 times, and if they missed just one, the material would have come out imperfect. So they had to be very careful and watch what they were doing. Now, I would have thought we'd have done a yard or two just to make sure everything was correct. If we'd have done all 800 yards of an imperfection running through it, they'd have been on the buy. So it was important it was set up correctly. Now, as well as going through the little eyelets, the threads would also go under these. Now, these are called drop lines. So when the machine is set up correctly, all these would be up in the air like that. Now, if an end was to break, that would drop, that would turn the machine off instantly, and the weaver can find his broken end straight away. It just saves him having to trawl through all 4,400 ends, which would probably take most of the day, and it would have been a nightmare. So it works exactly the same as the weft fork on these machines, so exactly the same principle. Right, now, this book, this is called a pattern book. And somebody would sit down and work out the pattern, you put the little dots in the grids, and that gets copied from the book onto the punch card, and that's how the patterns were created. Now, to be honest with you, it's a bit like a foreign language to me, but somewhere, just by looking at this, tell you what pattern it's producing and what colours they would want putting in that pattern. So again, very skilled work. So what we'll do now, I'll show you a more modern loom down on the end. Then as we walk into the next department, I can show you a little machine which was used to punch the holes into the cards. Now, just as you walk past, this is exactly the same as the machine I've just shown you, but this one's been set up a bit better. So without the drop lines, trying to find a broken end and all that lot, yeah, you've had a problem. Right, Right, now we do normally run this loom, but it's currently under repair. It's been quite cold this winter down here, and some of the ends of the warp have broken and it's been damaging the cloth. So it is currently under repair. The old looms never have a problem with. These more modern ones, a bit more temperamental, and they give us a bit of a headache. So this is a Sarah loom. This was built in Switzerland in 1978. This can't produce an intricate pattern like the jacquard. This is restricted to twills, tartan effects and checks like we're trying to produce at the moment. Now it is similar to the jacquard. This has also got a multi-shuttle system. We can use up to 4 shuttles in this loom to get different colours in the pattern. And this loom also uses punch card. The punch card goes inside this box. It goes around 2 rollers. You've got the set of pins at the top, same as the jacquard, which helps create the pattern. Now, these looms are twice as fast as the old looms, and they're also twice as loud, and you could find 500 of these in a shed all going at the same time. Now, on the old looms, you've got the metal of the shuttlet in leather. On this one, it's metal on metal, so you get that horrible clanking noise. Now, the speed of a loom is measured in picks. A pick is the shuttle going across just once. So the old looms, they do 90 picks a minute. This one does around 160 picks a minute. The modern ones in India and China, they do 2,000 picks a minute. So that's just taking it on to another level. How do you achieve that? What they do, they don't use perns or shuttles anymore. You have a cone of thread like this attached to the loom, then you use jets of air to fire the thread from left to right. The beauty of that is they're a lot quieter, and also you don't need somebody stood next to it all day changing the perns. As long as you've got a good cone like this, it pretty much run all day without any interference. So, that's the looms. As you have a walk down into the next department, this is the little machine I was telling you about. A bit like an old typewriter, and there would have been a room full of them producing the patterns. Now, again, nowadays it's all done by computer, but if you've got halfway down and made a mistake, you'd have to start all over again, or if it got missed and put on the machine, the pattern would be thrown completely out. So, yeah, that's that, and we'll have a walk down into this department. Right, so we're going back to the start of the process now. This is what this mill used to do. This was purely a cotton spinning mill. The looms have just been brought in from elsewhere to complete the process. So this is a bale of raw cotton, and this would have been shipped over from America. Now there's quite a few seeds and husks in the cotton, and they need to be removed before it can be carded. Now this is the first machine in the process. This is a bale breaker called a fear-naught, a very apt name, as it feared nothing. Now, the workers, they had another name for it. They called it the devil, as it was an evil machine, not unknown to take fingers and limbs. And also, it wasn't uncommon as the spikes went round for them to grind on each other, which would create a spark, and that would send all the cotton up in a big fireball. So when this machine was running, it would have had numerous buckets of water all around it, just in case. So the cotton from the bale, that will go in that end. These rotating spikes opens the cotton up, shreds it, and cleans it. All the seeds and husks, waste, that will fall to the bottom of the machine, and somebody would have to remove those plates, go underneath and clean it out. Now, as the notice says, the machine would have been turned off for a female or young person, but a man would have to take his chances and go underneath while these spikes were going around just inches above his head. So, not a pleasant job, and there's no emergency stop button. The only way you could stop it is by stopping the line shafting, and then because of the momentum, it would take a minute or two for it to come to a complete standstill. So if you got caught in this machine, you was as good as dead. It is a gruesome machine, but it did do a job. And when the cotton comes out this end, it would look something like that. It's a rather coarse clump. Now, before it can be carded, it needs to look and feel like soft cotton wool. If you'd like to have a walk down, I'll show you the next machine. Right, so this is the next machine in the process. This one's called a sculpture. So the cotton from the devil would get thrown into this part, which is the hopper, and that would take it onto a conveyor full of spikes. But the spikes in this machine are a lot finer. So as the cotton passes through, it's getting more of a thorough clean. And it drops down a chute, goes through various rollers and a few more spikes, and it will come out the other end looking like that. That's a nice soft cotton wool, and that's ready to be carded. Now this machine running for just 1 minute would have produced enough cotton to fill 22,000 of these 75-yard bobbins. That just gives you some idea of how much cotton was produced. The reason being, in Lancashire in its heyday, there was actually more looms than people. So the demand was so great, places like this constantly churned out thousands and thousands of miles of cotton every day. So we've now got a nice soft cotton, and this would have normally gone into one of the old carding machines down at the bottom end. But we haven't got any of those working at the moment, but I can show you a more modern one, which is just back on your right hand side, and get this one working. Now, I do cheat a little bit now. I'm using wool and not cotton, but this is just for demonstration purposes. But this is what the cotton would look like when it comes from the sculpture. All the fibres are tangled and they need to be combed straight before it can be turned into thread. Now, this is a sample carder, and this was used to blend different types of wool, but it does exactly the same job as a cotton carder. It's exactly the same principle. So the cotton would have gone onto a conveyor like this and gets fed slowly into the machine. The larger rollers with the fibres on, they're called workers, and the smaller rollers in between the workers, they're called strippers. They take the fibres from the workers and pass them through the machine. It then goes under this large central drum, which is called a doffer, in between these two rubbing mats, and it gets wound onto this metal drum as 10 strands of roving. On the large carding machines down there, the cotton would have been wound onto this wooden beam as 34 strands, and it would have looked the same as the one on the end, just there. Round, it would have released white cotton fibres into the air, and at the end of his shift, the man operating these machines, it looked like a snowman. It'd be covered from head to toe in these white cotton fibres. He'd spend all day breathing these fibres in, which again would get in his chest and his lungs, and it caused him all sorts of health problems. Right, so that's the carding. If you'd like to have a walk down this passageway just in, and I can show you the final machine in the process. Right, so this is what the cotton would look like when it's being carded. Now, as you can see, it's very weak, and it needs to be spun or twisted to give it strength. Now, this machine I'm studying, this is called a spinning mule. This was invented by Samuel Crompton, and it's a combination of Arkwright's wood frame and Hargreaves' spinning jenny. This particular one, this was built in Oldham in 1907, and it's one of the longest in the world. It stretches from here all the way down to the far wall. explained, the cotton comes from a carding machine and gets wound onto this wooden beam. That would then get lowered onto this drum, goes through the small rollers and into the mule. Now the spinning mule is on a carriage, and this carriage would have come out on these tracks which are bolted to the floor. Now as the carriage comes out, the spindles go round, so the cotton's being drawn and twisted at the same time. That takes it from a very weak cotton and turns it into a nice strong thread. And the carriage, as it comes back in, it will put what it's just made onto a pern. Like that. So we've gone from the bale of raw cotton through the 4 machines. We've now got a nice strong cotton thread, and this could have been passed on to the weavers, and they'd have used this to make their cloth, as we saw at the start of the demonstration. So that takes us full circle, completes the process. But before I finish, I'd just like to show you this photo. Now, I don't know if everyone can see, but there's a man stood there. Now, he was called a mule spinner, and it was his job, as well as the uptake and maintenance of the machine, it was his job to walk in and out of the carriage, locating and repairing any broken threads. Now, as this was such a complex machine, he had to be highly skilled, and he was paid accordingly. He was the third highest paid man in the mill. Now, most people who worked in the mill at that time was on the equivalent of 50 pence a week, but the mule spinner, he was on £7 a week, so there was quite a big difference. Now, also in the picture, there's a young boy sat there. Now, he could be as young as 6, and it was his job, as the carriage came out, he would have to go under the machine and pick up any of this waste cotton, what might have fallen on the floor. And he'd have to get back out pretty sharpish before the carriage came back in and potentially caused him injury. Now, the carriage that could come out and go back in up to 4 times a minute, so it would have approximately 15 seconds to get in from the back, get what he could, and get back out again. All the cotton that would have been gathered up and put back into the devil, and that would just go back through the process. Cotton was money, and none of it would have been wasted. Now, I did mention that the mule spinner would have got £7 a week, but out of that, he would have had to pay the young children. So, what he'd do, when his children was old enough, he'd come up with an excuse to get rid of them children, bring his own children in, and all the £7 would have been going in the same pot. So he did crafty. He got around. So that brings us to the end of the demonstration. We have got plenty more to see. There's the Victorian workshop at the end of this room. Where the blue post is at the on your right hand side, that will take you into the bobbin room, and you can go outside, see where the water wheels used to be. You'll go round the back and you'll finish in the boiler house. If anybody's got any questions, I'll do my best to answer them. So I'd just like to thank you all for your visit.
Thank you.
Just one question. Sorry, there's one question. What did they do before the carding and so on, before 1905? You've got this machine that this was built in 1905. What happened before that? What did they do before that?
Before this one, it was the Market's water trade and things like that.
Oh, right.
Which did the spinning.
Yeah.
And Argyll spinning Jenny. Then Samuel Crompton, he just, when the patents ran out, he just fused the two together and he invented this. Whereas Arkwright's wood frame could only do about 92 spindles, this one does over 700. And then you've got one this side as well, so you're getting 1,400. So this is just mass production, this one.
Yeah, yeah.
So we've taken Arkwright's little machine and just developed it in.
Yeah. Okay, thanks.
Thank you.
You meant, you said water frames? Is that what you said? Where are they?
We haven't actually got any here. I think there's one last Romanian one in a museum in Bolton, I think it is. But yeah, I think back then you just got